Okay, so I did the first example with you. Okay, and I told you sketching, you're more than welcome to choose whichever method you want, whether it be table method, browse overrun, but the easiest one is going to be dual intercept. Okay, dual intercept is your x and your y intercept. Okay, then I'll go to this one. Okay, we are going to interpret our equation. What do they give us? Okay, what is this g of x is equal to y? What is that negative 2x? That negative 2 is what? That's your gradient. Y equals mx plus c. M is your gradient. Okay, so this is your gradient. And we know if our gradient is less than 0, we're going to have a decreasing linear function. So our graph is going to go like that. Understand? Okay, and then normally we have a plus c there. And that plus c is our y-intercept. Do we have a plus c here? Okay, so this is non-existent. It's 0. So we don't have a y-intercept. Okay, this is telling me that my straight line graph is going to cut through my origin. Okay? So technically speaking, my graph, if we look at the Cartesian plane, it's going to cut through here, going that way. Do you see how it cuts here? It's 0 and 0. It's got no y in it. But then I told you it's vitally important for us to at least have 2 coordinates in order for us to sketch. But now we've got a problem. We don't have a point. Do you see? Okay, so for our x-intercept, okay, x-intercept we can go find. For our x-intercept, we're going to make y is equals to 0. Okay. So hold on, let's check here quickly. Okay, so do you see over here how we're going to do x-intercept and y-intercept? But now the problem is with my y-intercept, I don't have a y-intercept. So I can't just go and plot that point. So x-intercept we can go and choose, we can go and find. Let's see it on the next page quickly. Okay. Okay, x-intercept, I'm just going to do it up at the top here because I don't see it here. Okay, my x-intercept, what do I go make equals to 0? Okay, I'm going to show you something now. To get x on its own, we divide both sides by 2. So do you agree x is going to be 0? So do you agree my x and my y-intercept I get 0 and 0? Okay, so I've got no x-intercept and I've got no y-intercept. But it's not no x and no y. We just know it's going to pass through the middle, the origin. So do you agree we have one coordinate already? Yes. And that coordinate is 0 and 0. My x-intercept is 0. My y-intercept is also 0. So our first coordinate is at 0 and 0. Problem, we still need at least one other coordinate. Okay, so instead of us now substituting x is equals to 0, because that's then going to be a y-intercept, right? We're just going to go substitute x is equals to 1. So we can have one other coordinate. You can go substituting negative 1 if you want, or 2, or negative 2, or 3, or negative 3. It's just easiest to use 1. Okay. Yes. So remember I said to you, when we substitute x is equals to 0, the x part of my coordinate will be 0 and we need to go find its friend y. If we go substitute in x is equals to 1, a part of my coordinate, x is going to be 1, and we'll need to go find its friend for y. Okay, so wherever there's an x, I'm going to go put in 1. I get y is equals to negative 2. Do you see? There's my second coordinate. When x is 1, y is going to be negative 2. So do you see? Here's my 2 coordinates that I'm going to plot. 1 and negative 2 and 0 and 0. Okay, if we had to sketch our two coordinates is to the origin at 0 and 0, are you with me? And our second coordinate, where we substituted 1 in, we got our y coordinate to be negative 2. Here's our first coordinate at 0 and 0. Our second coordinate is at 1 on the x-axis, negative 2 on the y-axis. All you do is you join your dots and you label your graph G. Okay. Okay, then we've got special graphs. Okay. Right. So we've got a first one that is exactly 100% vertical. Okay, so can you see that this line cuts only at 3? Okay, but which axis does it cut at 3? Okay, so that's why the equation of this line is x is equals to 3. Understand? Okay, then I've got another question for you. This graph looks exactly like a wall. Are you with me? That's standing up vertically. Are you going to go and walk up that wall? Okay, which means the gradient of a vertical line is undefined. It's impossible. Are you with me? Are you guys okay? You can't go and walk up a wall that's 100% vertical. Okay? But then if you look at the graph on the right hand side to that, okay, this one is 100% horizontal. And which axis is it cutting? The y-axis. That's what the equation for this line is. Y is equal to 6. Okay. Then a graph that's 100% horizontal is like a floor. Okay, does a floor have any gradient? Okay, which means if it's a 100% horizontal line, your gradient is going to be equal to 0. Okay, see the difference between a gradient that's undefined and a gradient that's 0. Okay, finding the equation. So what we just did is, they give us the equation and we must go and draw it. Now they're going to give us the drawing and we must go find the equation. See the difference? Okay. Find the equation of a line that passes through points negative 1 and 2 and negative 2 and negative 3. Okay. So when we're finding the equation, the first step, what I need you to do is, I need you to write down the general form of a linear graph, which is y is equals to mx plus c. Okay, that's what we're going to do first. And when we need to calculate the equation of a straight line, there's only two things you need to calculate. We need to calculate the gradient, which is m. And we need to calculate c, which is our y-intercept. Okay, this x and this y just counts as a random coordinate on the graph that you'll need to substitute somewhere along the line later, that I will show you. Okay, so when we need to calculate the equation, let's start with finding our gradient. Okay, when we need to calculate our gradient, there's a little formula you need to study off by heart. Okay, and this formula is, the gradient is y2 minus y1 over x2 minus x1. All that is that x and the y coordinates of the 2 points that they give us. Okay, so where are my 2 coordinates they give us? Here's the first one. So let's label that x1 and y1. It's the x and the y that makes up a coordinate. Okay? And here's my second point. Let's make that x2 and y2. Okay, now what I like to do is I like to use color because this can be a little bit confusing at times. Okay? I know that my first 2 pieces of my coordinates, both of them are going to go in at the bottom. And I know that the second part of my coordinates, both of those are going to go in at the top. Now the mistake you're going to make is you're going to put both of those at the top or both of those at the bottom and vice versa. Okay, but you see how you need to pair your x's and you need to pair your y's. Another mistake is don't put your x's on top and your y's at the bottom. You need to study. Now, good question. Does it matter which one I choose as x1 and y1 and whatever? No. The only thing is it's going to be your signs, but you will land up with the same answer. Okay. So, it seems as if now you see, this worked example used this. Oh, that's right. Okay, but I'll show you on the side if you had to swap your coordinates around, you'll land up with the same answer. Okay. So, y2 is minus 3 minus 2. Are you with me? And here we've got minus 2 minus from the formula, but x1's value is negative 1. So you're going to double negative that, but you're going to put it in a bracket. Okay. This negative and a negative is going to become a plus. Okay, so minus 3 minus 2 is minus 5. Minus 2 plus 1 is negative 1, and your answer is going to be 5. Okay, so let's see if we have to swap it around. We go 2 minus from the formula and a negative 3. Are you with me? And for my x's, we'd say minus 1 minus a negative 2. Okay, so this would be 2 plus 3. And this would be minus 1 plus 2. So what is 5 divided by 1? Still 5. Okay, can you see? Just the story of your signs, making sure you double negative, you don't forget that. Okay. Right. So far, what do we have? We've got y is equals to, in m's place, I've got a value for m now. I've got the gradient. And my gradient is? Okay, so that m falls away and I substitute my value of m into the formula, and it is 5. Are you happy? Okay. The next problem I've got is I need to go and calculate my value for c. So it's basically like a normal equation. Remember with equations, we can, unless it's simultaneous, we can only calculate one variable at a time for a linear equation. So if we need to calculate c, this x and this y is a problem. So we need to substitute something in to x and y. So we just have c as an unknown. Are you with me? Okay. So, what we're going to do is, you see, one variable. What we're going to do is, this x and this y, remember I said to you that x and y counts as a coordinate. Because a coordinate is made up of the x and the y. Okay? We're going to take any one of these points, and we're going to go and substitute it in to x and y. Are you with me? Okay. So, whichever coordinate you pick, you will land up with the same answer. Okay, so I'm going to pick point 1. Okay, and I'm going to go substitute it in. So, in x's place, I'll go put negative 1. And in y's place, I'm going to go put 2. Because remember, what do I have? I've got y is equals to 5x plus c. So in x's place, I'll go put in negative 1. And in y's place, I'll go put in 2. Can you see what I'm doing? By doing that, I eliminate the 2 unknowns in my equation. And I'm only left with c. Are you with me? Okay, so 5 times negative 1 is negative 5. We're all the way back to normal linear equations. If I want to get c on its own, I'm going to go take the 5 over, and it becomes a positive 5. And what is 2 plus 5? 7. Therefore, my equation for this graph is y equals 5x plus 7. Okay, right, then we've got perpendicular and we've got parallel lines. Okay, listen to me quickly. If I've got 2 lines that are parallel, it means they go like that. Okay, which means their gradients are going to be 100% the same. The gradient of this one will be the same as the gradient of this one because they're parallel. Remember, parallel lines never meet. They're the same distance at every point, which means their gradients are going to be the same. Okay, so that's where I get this from. Parallel, okay, let's do this one. Parallel lines, their gradients are equal to one another. Are you with me? Okay. Okay, so for example, this one here, your graphs are they're going to give you two graphs. They're going to go like this, like that, and like that. Those ones' gradients are the same. Okay? If I have two perpendicular graphs, watch here. The gradient of the first line, so if we had to look at it on a Cartesian plane, we'll have a graph going here, and we'll have a graph going there. Okay, at a 90-degree angle, because they're going to be perpendicular. Okay? What do we know about the gradients of perpendicular lines? The gradient of the first graph times the gradient of the second graph. When we multiply them together, it must equal -1. Know this off by heart, please. Okay, very important. Okay, so for example, a line parallel to line y equals 2x plus 7. Okay, so let's just say, for example, they give you this graph. Okay, they give you this graph on the Cartesian plane and they say, this thing's equation is y equals 2x plus 7. Okay? And then they say to you, okay, cool, well, here's another graph down here that is parallel to that one. What is the equation of that? But they give you no points except for this one. Let's say that's like -2. Okay, so first things first, we know what the y-intercept is. The y-intercept is y equals -2 here at the back. Okay? Then we need to go calculate the gradient. But how on earth must we do that if we only have one coordinate? Okay, use the other piece of information. They tell you that the two graphs are parallel. Okay, parallel. Which means the gradients are the same. Which means the rest of this equation is going to be 2x. Okay, next one. What am I running? Okay, a line perpendicular. Okay, so there's your hints. Okay, it's perpendicular. What do we know about perpendicular lines? The gradients of the first. Okay, so they're telling us that they're perpendicular. So we've got the first line, which is y is equals to -2/3x plus 6. Okay, that means that the graph perpendicular to this one, okay, is going to have a gradient of positive. Okay, so let's just say here. Okay, what they're asking us to find the equation of that line. Okay, so first things first, we know we start off with a general form. Y equals mx plus c. They tell us that the two lines are perpendicular to each other, which means the gradient of the first line times the gradient of the second line must equal -1. What is the gradient of the first line? Positive, -2/3, right? Do we have the gradient of the second line? Okay, it's what we want to calculate. Are you with me? Okay, so I'm just going to leave it as m. My other gradient I want to calculate. So I'm solving for x. Okay? How do I get m alone on the left-hand side? If I am multiplying, we need to divide both sides by -2/3. Are you guys with me? Hello? Yes, ma'am. Okay, so -1 divided by -2/3 is going to give me 3/2. That means the gradient of my second line is going to be, can I look? We know if we multiply them together it must give me -1. Okay, so this is the gradient, the original one is -2/3. What is the gradient of the one I just got? Okay, 3 over 2. When we multiply them together, does it give me negative 1? Okay, so we're right, we're good. Okay, so I've got, you see here, I showed you how to get that positive 3 over 2 now. Okay, now the problem is we need to go and find C. And now we're going back to what I just explained. If we need to calculate C, we can't have X and Y there as well. Because we can only solve for one variable at a time. So what are we going to go and substitute in to X and Y? A point. Do they give us a point? Yes, look here. Find the equation of this line that goes through negative 1 and 3. Are you with me? Okay, so in X's place, I'm going to go substitute in negative 1. Can you see? There it is there. Great sense?
Yes, ma'am.
Okay, and in Y's place, I'm going to go substitute in, which is here. You guys okay? Right, now all I do is back to normal linear equation. 3 over 2 times negative 1 is negative 3 over 2. Take that over to the other side, it becomes a plus. Put that into your calculator and you get 11 over 2. Therefore, the equation of the line perpendicular to this one is going to be y is equals to 3 over 2x plus 11 over 2.